I want to continue our discussion of the unit circle, and in this particular video, we're going to kind of I want to show you kind of where the numbers come from, that it's really not magic, that there is a pattern to the measurements on the unit circle, which will hopefully help you learn it. So as we begin thinking about it, let's think about, first of all, what we would call our quadrantal angles, okay? Quadrantal angles, remember, are the ones that occur on the axis. So if we start here, we have our angle in standard position. We could have no rotation, which would be 0 degrees, or in terms of pi, it's 0, okay? And because we know we have the unit circle, which is in the form x squared plus y squared equals 1, we also know that our ordered pair, which is normally x comma y, now becomes the cosine of the angle comma sine of the angle. Our degree measure here, or if you go from the center out, that's 1 radius. So this would be the ordered pair 1 comma 0. So we know that in this case, the cosine of 0 has a value of 1, and the sine of 0 has a value of 0. Now, this same angle could be, if you rotated it all the way around the circle, okay, that would correspond to 360 degrees, or 2 pi. But it is the same, it is the coterminal angle. 0 degrees and 360 degrees are coterminal angles. They have the same terminal side. The second quadrantal angle, okay, that we can think about is the 90-degree angle. If you go from the center straight up on the y-axis in the positive direction, okay, so that you've rotated 90 degrees, or pi halves, okay, 90 degrees or pi halves. And again, you think about the point here, this would be the ordered pair 0, positive 1, which tells me that the cosine of pi halves is 0, and the sine of pi halves is 1. Okay, and it's based on just that point, which you can recognize based on the relationship on the coordinate plane. Okay. Third, you could have an angle that basically goes halfway around the circle. If you start in the standard position with your initial side on the positive x-axis, and we rotate halfway around, so that basically you have a straight angle that's 180 degrees, or pi units. And so then we think about this point that lies on the terminal side, and that point would be -1, 0, because I've gone to the left of the center, so I've gone -1 unit. The negative just simply implies that we went to the left as opposed to the right. So again, thinking about what that means, that tells us that the cosine of pi is -1, and the sine of pi is 0. Now we could think about the other trigonometric functions as well, but those are the two that we're going to focus on for now. And then finally, if we rotated, we start again with our vertex on the origin, our initial side on the positive x-axis, and we rotate that far, so that I've rotated basically to the negative y-axis, okay, which is actually 270 degrees, or 3 pi over 2, and I think about this point where the terminal side intersects the circle, that point is 0, -1, which tells me that the cosine of 3 pi halves is 0, and the sine of 3 pi halves is -1. Now, hopefully you're familiar with reading points on the coordinate system, and so that's going to help you relate it back to specifically sine and cosine for an angle. So I would encourage you to learn those four basic quadrantal angles. Notice they're multiples of 90 because you have 90 degrees, 180 degrees, 270, and then 360 would take you all the way back around. We can also superimpose on top of the unit circle our 45, 45, 90 triangle, and we know that our hypotenuse would be the radius, which is 1. So our hypotenuse corresponds to the radius, and then if we draw the corresponding triangle, okay, to make the right triangle, then if we use our relationships that we know, or even use Pythagorean theorem, we can figure out what this ordered pair would be. Remember, for the 45, 45, 90 triangle, that these two sides, which represent our x and y here, are the same length. Okay, so for now, I'm just going to call them, let's just call them maybe an L for leg of my triangle. Okay, so if I have leg squared plus leg squared, and that equals 1 squared, because it's a squared plus b squared equals the hypotenuse squared, I would have 2 leg squared equals 1. If I divide both sides by 2, I have L squared equals 1/2. I'm then going to square root both sides. Again, I'm looking at a distance, so I have the length is the square root of 1/2, which I need to simplify, break it apart. Square root of 1 over square root of 2 is 1 over square root of 2. Then I need to rationalize that denominator by multiplying by square root of 2 over square root of 2, which ultimately gives me square root 2 over 2. So the leg of my triangle, my 45, 45, 90 triangle, is square root 2 over 2. So I would move horizontally square root of 2 over 2, and then I would also move vertically square root 2 over 2 because they're the same, which means this ordered pair here, where my terminal side ends or stops on the circle, is the ordered pair square root 2 over square root 2. And notice that my triangle here is in the first quadrant, okay? We're thinking about 45 degrees, which is the same as pi force if you think about it in radians. So for pi force, the corresponding ordered pair, or if you think about it in terms of sine and cosine, we're saying that the sine of pi force is square root 2 over 2, and the cosine of pi force is also square root 2 over 2. Notice it's the same value because the two legs or the two lengths are the same size in the triangle. The other thing that I want you to think about, because again, one of the things the unit circle does is it allows us to go beyond acute angles. I don't have to just deal with a 45-degree angle, because I could take that same triangle, and instead of placing it or drawing it in the first quadrant, I could draw that same triangle over in, say, the second quadrant. Okay, so we need to think about what angle that would be. If we start with our initial side and we rotate until we're in the second quadrant, and then think about our triangle, so that I really want this angle here to be 45 degrees. Okay, so that I have a right triangle. And again, I know that my hypotenuse, which corresponds to the radius, has a value of 1. Okay, so we know that all the way around would be 180 degrees. So 180 degrees minus 45 would give us 135 degrees, or 3 pi over 4. Okay, so this triangle, which is in the second quadrant, okay, it's still a 45, 40, 90 triangle. So I'm still going to have the two legs, and I'm going to get the same measurement. But the deal is, now I'm in the second quadrant. In the second quadrant, remember, your first coordinate, or your y coordinate, is negative. So this ordered pair would be negative square root 2 over 2, positive square root 2 over 2 for the y. So it's the same triangle. We get the same values if we go through when we do the math, but we're in the second, because our terminal side is in the second quadrant. We know from earlier algebra days that the y coordinate, the x coordinate is negative. So we say the cosine of 3 pi fourths, which corresponds to x, would be negative square root 2 over 2, and the sine of 3 pi fourths equals the y coordinate, which is square root 2 over 2. And because it is a multiple of 45 degrees, we get that same ordered pair, but you have to alter the signs because of the quadrant that you're in. Continuing that same idea, if we took our 45 degree triangle and we drew it in the third quadrant, I'm a little bit off there, but maybe you can see it. Okay. Okay, so that again, if you think about starting on the terminal side and rotating, so we rotate the 180 degrees, and then we go an additional 45 degrees. So 180 degrees plus the additional 45 degrees to get us into the third quadrant is 225 degrees, or 5 pi over 4. So again, I know that my radius, or my hypotenuse, has that value of 1. Again, I'm going to get the same ordered pair that I've gotten previously for my 45, 45, 90 triangle, but I'm in the third quadrant. And in the third quadrant, remember that your x value and your y value are both negative. So I'm just rotating it, or moving the triangle around the circle. I get the same values, but I have to use the appropriate signs, S-I-G-N, S, on the ordered pair. So we now know that the cosine of 5 pi fourths is negative square root 2 over 2, and the sine of 5 pi fourths is also negative square root 2 over 2. Remember, cosine corresponds to your x, sine corresponds to your y, but in the third quadrant, they're both negative. And then finally, if we rotate that 45 degree triangle into the fourth quadrant, Okay. Again, we know that the radius or the hypotenuse is 1. And again, if you think about the rotation, you've rotated 180 degrees, additional 90 degrees, which would be 270, and then we've gone 45 degrees more. Or you can think about it of a total rotation is 360 degrees. We're going to be short by 45 degrees, which gives us an angle measure of 315 degrees, or 7 pi fourths. This time our terminal side is in the fourth quadrant, and in the fourth quadrant you have a positive x and a negative y. Okay, so we would have square root of 2 over 2, comma, negative square root 2 over 2, so that we can see that the cosine of 7 pi fourths is the x coordinate, which is square root 2 over 2, and the sine of 7 pi fourths would be negative square root 2 over 2. So here's the deal, guys. If you will learn this first quadrant, that pi fourths corresponds to the ordered pair square root 2 over 2, and then realize that you can rotate that all the way around the unit circle, you end up with all of the different values, and you just alter the signs of the ordered pair depending upon which quadrant you're in. Now, similarly, we can do the same thing with a 30, 60, 90. In one case, we put the 30-degree angle at the vertex so that we've rotated Okay, so you have your 30-degree angle at the vertex, which means the one here is your 60-degree angle. It depends on how your triangle is oriented. Okay, so remember that 30 degrees corresponds to pi 6 if you do the conversion. And again, if we know that our hypotenuse is 1, and if you think back, we know that the hypotenuse of a 30, 60, 90 triangle is 2 times the short side. Okay, so 2 times the short side. Well, if the hypotenuse is 1, and we know that 2 times that short side is going to it's going to give us the short side, and I simplify that or solve it for the short side, I have that the short side of our triangle is going to equal 1/2. Well, if you look at our picture in this particular scenario, the short side, which is opposite the 30 degrees, okay, remember the short side is opposite 30 degrees. So that's going to actually correspond to what would be the y value of the ordered pair. So I know that the short side has a value of 1/2. Once I know that short side and I already know the hypotenuse, I can use Pythagorean theorem to find the long side, or the side opposite 60 degrees, which would correspond to x. So I would have x squared plus 1/2 squared, that's our short side, equals 1 squared. So I have x squared plus 1/4 equals 1 whole. I'm going to subtract 1/4 from either side so that x squared equals 3/4. I'm then going to square root both sides. Again, I'm using so I have square root of 3 divided by square root of 4, which simplifies to square root 3 over 2. So the x-coordinate of my ordered pair that corresponds to this point is the square root of 3 over 2. Okay, so at pi sixth, I would have square root of 3 over 2 as my cosine and positive 1/2 as the sine. And again, it's all related back to the relationships of that 30, 60, 90 triangle. And again, I can take that same triangle and rotate it around into the other quadrants. So let me show you one real quick. If I take that same 30, 60, 90 triangle, and again, I rotate it so that I'm in the second quadrant. Okay, so there's 30 degrees. Here would be 60 degrees. And I think about the rotation, I would have gone not quite to 180 degrees. So I have 180 degrees minus the 30 degrees, which gives me 150 degrees. In terms of pi, that's 5 pi over 6. Okay, but again, the deal is I have that 30-degree angle. So because it corresponds to a 30-degree angle, notice it ends in sixth, I'm going to have that same ordered pair, but since I'm in the second quadrant, okay, since I'm in that second quadrant, my ordered pair has to be negative square root 3 over 2. The x-coordinate is negative, and the y-coordinate would be positive, okay, because I'm in the second quadrant. And again, you can continue to rotate around. If I rotate around to the third quadrant for that triangle, whoops, a little bit off, okay, so that I have a 30-degree angle and I'm in the third quadrant, okay? In that case, I've actually rotated a full 180 degrees and I've gone 30 extra. So 180 degrees plus the 30 extra degrees is 210 degrees, which is the same as 7 pi sixth. But again, now I'm in the third quadrant, and in the third quadrant, the two ordered pairs are going to be negative. So I have negative square root 3 over 2, negative 1/2. Okay, it's the same set of ordered pairs because it's a multiple of 30 degrees or a multiple of pi sixth. And so I have the same ordered pair, but I have to fix the signs based on the quadrant. And again, if we go finally into that fourth quadrant, the fourth quadrant, I've not quite made a full revolution back around to 360 degrees. So I would have, my rotation would be, let's see, 90, 180, 270. I'm not quite to 360. So 360 degrees minus 30 degrees is 330 degrees, or 11 pi over 6. And again, I'm in the fourth quadrant now, so my ordered pair would be positive square root 3 over 2. You get a positive x, and negative 1/2 because you get a negative y value. Okay, now finally, the last thing you can do is, instead of having that 30-degree angle at the origin, you can actually have that 30, 60, 90 triangle drawn so that you have the 60-degree angle at the origin. Okay, so I would have now I have the 60 degrees at the origin and the 30 degrees, and we still know that the hypotenuse is 1. So I've just reoriented my 30, 60, 90 triangle to now think about a 60-degree angle. And again, if we go back and we think about our 30, 60, 90 triangle, we know that the hypotenuse is 2 times the short side. Okay, so but in this case, our short side, which is opposite 30 degrees, corresponds to x. So my hypotenuse is 1, and then I have 2 times x, because that now represents my short side. And if I solve for x, I have 1/2 equals x. So the x coordinate of this point is going to be positive 1/2, again, because I'm in the first quadrant. Then I can find the corresponding y coordinate, again, by using Pythagorean theorem. I know that my x is 1/2 plus the y equals 1 squared based off of the circle. So I have 1/4 plus y squared equals 1. Subtract 1/4 from either side. So I have y squared equals 3/4. And then I'm going to square root. Again, I'm in the first quadrant, so we know it has to be positive. So I have y equals square root of 3 over square root of 4, which simplifies to square root 3 over 2. So the y coordinate here for this ordered pair is square root 3 over 2. Okay, notice how they flip-flop. This is a 60-degree angle, and 60 degrees corresponds to pi thirds. And again, at that point, we can begin thinking about rotating around the circle with our 60-degree angle, okay, so that we're in quadrant 2. If we're in quadrant 2, we have our 60-degree angle at the center. Okay, and we think about our rotation. We've rotated 90 degrees, or we're short. So I have 180 degrees minus the 60 degrees, which is 120 degrees, or is pi. Ooh, I forgot what that one is. 2 pi thirds. I'm sorry. It's 2 pi thirds. Again, it's a third, so now looking at multiples of thirds, I'm in the second quadrant. In the second quadrant, you have a negative x value, so I'm going to have negative 1/2 and positive square root 3 over 2. Okay, notice it's the same ordered pair, but we just alter the signs because of the quadrant we're in. If I rotate around to quadrant 3, with that 60-degree angle, again, thinking about my rotation, I've gone 180 degrees plus an additional 60. So 180 degrees plus an additional 60 degrees is going to be 240 degrees or 4 pi thirds. But I'm in the third quadrant. It's going to be the same ordered pair, but because I'm in the third quadrant, it's going to be both negative. So I have negative 1/2, comma, negative square root 3 over 2. I hope you're recognizing a pattern of how this rotation deal, so that basically if you learn one quadrant, primarily the first quadrant, you should be able to find all the others by simply altering the signs. And finally, if we look at the fourth quadrant, we've not quite rotated all the way back around to 360. We've gone 90, 180, 270. We're not quite around. So 360 degrees minus 60 degrees is 300 degrees, and that would be 5 pi thirds in terms of pi. And again, now I'm in the fourth quadrant, and we have a positive x, so 1/2, and a negative y, negative 3 over square root of 2. Okay, so basically what we've developed, and I try to do it in little pieces, you end up with a unit circle that looks like this. Again, there's patterns to it, guys, and so if you can learn, at a minimum, learn your quadrantal angles, okay, because those are special. Learn your quadrantal angles, and then also learn these in the first quadrant. Every multiple of 30 is going to have, or multiple of pi sixth is going to have the ordered pair square root of 3 over 2, comma 1/2. Okay, and you just alter the signs depending upon which quadrant you're in. Same thing, every multiple of 45 degrees is going to have the ordered pair square root of 2 over square root of 2 as your x and y, and again, you just alter it based on where you are. Okay, so there's patterns to this, and if you can learn at a minimum those 7, you should be able to determine all of the others depending upon which quadrant you're in. It's also going to help you to draw pictures of where you are and look at the different descriptions. And so we'll take a look at some examples of how to do this and begin looking at some of the relationships between the different trig functions in a separate video.